chemistry students. Today we are going over lesson 2.4, pressure versus volume. Please make sure you have already completed the lab before watching this video, as this video will go over the results of the lab. So I would prefer that you've already done it and collected your own data before we discuss it. So this is what your graph from the lab should look like. As you can see, as the volume of your syringe increased, the pressure dramatically decreased. We call this type of relationship inversely proportional. Basically, this means that variables do the opposite of one another. So when one variable increases, the other one decreases, and vice versa. To connect this back to our particle model, the reason for this is because pressure is the walls of the container. The less room particles have to move through, the more likely they are going to because there's simply no other place for them to be. Whereas if you have a larger volume, the particles can move through the empty space more and collide with the walls of the container less frequently. We can actually turn this inverse relationship into a mathematical relationship. So since they are proportional, we can calculate a missing piece so long as we know both values of one of the variables. So for our first example, we have a sample of helium gas in a balloon is compressed from 4.0 liters to 2.5 liters. If the initial pressure was 3.0 atmospheres at 4.0 liters, what will the pressure be at 2.5 liters? So the first thing I highly recommend do is you use the colored pencils or highlighters in your box to color code your variables. So I'm going to go ahead and, so anything that has an is going to be volume. So I have two volumes, 4.0 liters and 2.5 liters. So my V1 and V2 are those. From this, we can see that my volume is decreasing. Now I'm going to switch to orange for pressure. And I only see one pressure unit, which is atmospheres. So this is my only pressure. So P1, because it is connected to the 4.0 liters, is 3.0 atm. And P2 is my unknown. So to figure out what P2 is, first I need to figure out if the pressure should increase or decrease. I know that the pressure is inversely proportional to volume, which means that whatever volume does, pressure should do the opposite. Since the volume is going down, pressure is going to need to go up. So to increase my pressure, I'm going to take my initial pressure and I'm going to multiply it by the relationship between the two volumes. Since I want pressure to go up, I'm going to the larger volume on top and the smaller volume on the bottom. If I wanted pressure to go down, all I would need to do is flip these. And if you solve this and find that your pressure has actually gone down, you predicted it increasing, all you need to do is flip the two volumes in your calculator. So running this through a calculator, I'm going to take 3.0 times 4.0, which gives me 12, divide it by 2.5, and I get an answer of 4.8. There should only be 2 digits in my answer for significant figures. And then my unit should be atmosphere, because this is still pressure. All right, so that is our first example. Just to make sure you fully understand, let's do one more example. So example 2 says the pressure on a new set of tires changes from 105 kilopascals to 40.5 kilopascals as they bike up a mountain. What volume would their 9-liter tire occupy up the mountain? So I'm going to stick with my color coding. This time PA, even though it is not atmospheres, kPa is still one of the units of pressure we learned about. So I'm going to mark it. So this time I know both. P1 is 1 and 5. Kilopascals. P2 is 40.5 kilopascals. Based on this, I can see that my pressure went down. Now I'm going to look for my volumes. I only have one volume, which is this 9.1 liters. V1.1. I don't know what my V2 is. However, since pressure goes down, I know that volume must go up. So I'm going my 9.1 liters and multiply it by the ratio of pressures. Again, because I want my number to increase, I'm going to put the bigger pressure on top. Run this through my calculator, and I take 9.1 times 105, so I multiply by the number on top, and then I divide by the number on the bottom, which in this case is 40.5, and I get an answer of 23.59259. But I need to look at significant figures. I have 3 significant figures in both pressures, but only 2 in my initial volume, so I should only have 2 in my final volume. Rounding up, I get 24 liters. And that is how we solve problems relating pressure and volume. At this time, please go back and check your tracker and move on to the next assignment. I'll see you guys in the next one.